This is review video number 3, all about projectiles. So we're going to talk about some basic projectiles, things that are free-falling, things that are shot vertically, things that are projected horizontally from a given height, and things that are launched at an angle. So the first one we'll talk about is simply something free-falling. Okay, you have an object, let's say it's a ball, has a whatever mass it might tell you, it has a mass of 2 kilograms, and it's a distance of, let's say, 3 meters above the ground. Okay? So the first thing you should always do is make a list of your knowns. Okay? That should be number one thing to do, write your list of your knowns. Now, we know anything that's a projectile, anything that's in the air, we know the acceleration. Okay? Negative 9.8 meters per second squared. Make this pen a little bit smaller. Okay. We also know the distance is 3 meters that it's falling. Okay. And we also know its initial velocity. Initial velocity is 0. Okay. A lot of times people forget that initial velocity is 0, but it's starting from rest. Now we do know the mass, 2 kilograms. But the one nice thing about anything that's falling is that the mass doesn't affect it. Okay? Everything falls at the exact same rate, assuming there's no air resistance. And in Regents physics, we always assume that there's no air resistance. So you don't even have to worry about the mass. That's just extra information that you don't need. Now, from this information that we have, okay, they might ask you things like, how long does it take? What's the time to hit the ground? Maybe how fast is it going just before it hits the ground? So if we look at our kinematics equations, we know that we have Vf equals Vi plus At. We don't know Vf and we don't know T, so we can't use that because we have two unknowns in this equation. We can look at Vf squared equals Vi squared plus 2Ad. Now in this situation, we don't know Vf, we do know Vi, we know the acceleration, and we know the distance. So we could use this equation to solve for that final velocity. So it would just be simply a matter of Vf squared equals Vi squared plus 2Ad. Vi squared is 0, so we can just leave that in there as a 0. Acceleration is negative 9.8 meters per second squared. And our distance, to help get rid of that negative, because you can't take the square root of a negative number, our distance, or our displacement, is really negative 3 meters. It's 3 meters below where it started. So technically, that's negative 3 meters for our distance. All right. So if we do the calculations, do 2 times 9.8 times 3, take the square root of that information, and we come out with our final velocity of 7.7 meters per second. And that is downward. Now, most of the time they're going to ask for the magnitude. The magnitude, you don't have to worry about direction. But if it does ask for the direction, it is downward, which technically makes that negative. Remember, vertically, anything downward is negative, anything upward is positive. Now if you want to find the time, we can use Vf equals Vi plus At, or we could use D equals Vit plus 1/2 At squared. Okay. In this instance here, we now know the final velocity, but let's say we didn't know the final velocity. We would have to use this equation, D equals Vit plus 1/2 At squared. Oops. Where we know our distance at negative 3 meters. Vi is 0, so that makes that whole section 0. Okay. 1/2 times negative 9.8 meters per second squared times our t squared. Okay. So if we do the math on that one, it comes out to be a time of 0.78 seconds. All right. So that's a basic free-falling object. Now if we talk about something that's launched vertically, so it starts from the ground and projected upward. Now, a couple of things that we know. once that initial force projects that object upward, the only other force acting on it is gravity. Okay? So we have to look at this as two separate paths, one on the way up and one on the way down. So if this is the scenario, we know that at the top, its final velocity will be 0, because it stops for a split second until it starts to fall down. Now if we're looking at the path going downward, then the initial velocity would be 0. It doesn't matter. The one thing that's different between this and just an object falling is that the time up equals time down. Okay? So the amount of time it takes for that ball to get to that top position is equal to the amount of time it takes to go down. So if we want to find out how long this projectile is in the air for, which is a typical question, we would have to know the fact that we have the acceleration being gravity. Okay. We know VF. So from all of that stuff, we don't know the initial velocity that was launched up at. We don't necessarily know the height. So we'd have to do several steps in order to find that time. One of the first things that we can do, well, typically they'll tell you that it's launched with an initial velocity of something. Let's say it's launched with an initial velocity of 10 meters per second for nice simplicity here. So we can say VF equals VI plus AT. Okay, so our final velocity is 0, initial velocity is 10 meters per second, plus our acceleration due to gravity. Oops, I'll have to square it off up there. Times that time. Okay, that time comes out to be roughly 1 second. So that's the time to just go up. Then the time to go down will be double that, so total time of 2 seconds. Now if we look at something launched horizontally, so you have some sort of building or whatever it may be, a tower, and you've got an object being launched off the top of that, let's say 5 meters per second. Okay. As that object moves, its path would kind of look like this. So the horizontal velocity is constant. It's never going to change. But we have to break this one up into what we know vertically and what we know horizontally. So horizontally we know it's being launched at a speed of 5 meters per second. Vertically, we know its initial velocity is 0. We know acceleration is gravity. Okay. And let's see, is there anything else we know? Typically they tell us, the height of the tower. Let's go with 15 meters. Okay. So they tell us that distance, 15 meters. And one of the things I might ask is how far away from the tower does the ball hit, or how long is it in the air? Now, we cannot put anything from the vertical side into a horizontal equation, or anything from the horizontal side into a vertical equation. They have to be separate. Okay, we have to keep them separate. The only thing that can change sides here would be the time. The time can go on either side. That's the only interchangeable thing. So if we want to solve for the time, we can use d equals VIT plus 1/2 AT squared. So 15 meters, 0 for the initial velocity. This would just be gravity, and times the time squared. So we do 15 divided by 4.9, and take the square root of that. And we get 1.7 seconds. Okay. So that 1.7 seconds is how long it takes for that object to hit the ground. Now it could be any object, and it can be launched at any speed. It can be launched at 10 meters per second horizontally, because that does not factor into this equation. Okay? This equation, whether it's launched at 1,000 meters per second horizontally or 2 meters per second horizontally, it's still going to be in the air for the same amount of time. It's the old, if I drop a bullet or if I shoot a bullet, they hit the ground at the same time scenario. So now if you want to know how far away, let's just erase some of this stuff here. If we want to know how far away that ball hits from the tower, okay, we can do dH equals VHT. Horizontal distance equals horizontal velocity times time. So 5 meters per second times 1.7 seconds, and we get 8.5 meters. All right. Now, the last type would be something launched at an angle. Okay. Let's say that we have a ball launched at 30 meters per second. Oops. At an angle of, let's call this 50 degrees. Okay. The very first thing you do, the number one thing you're going to do, is break it up into components using these equations here. AX equals A cosine theta. AY equals A sine theta. Okay. That tells us AX would be our horizontal velocity, and AY would be our vertical velocity. Okay. So when we do that, we come out with our AX to be 19.3 meters per second, and our AY to be 22.9 meters per second. Now, a big mistake people make is that then they try to plug this value back in one of the kinematics equations. Once you've broken up into components, get rid of that. You never, ever, 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 ever need to use that again. Okay? We only use those components. So like I said, our horizontal velocity we know is 19.3, and we know our initial vertical velocity is 22.9. Other things we know, if we break it up into our knowns, vertical and horizontal. Now, the path looks like this. Well, kind of. And we always go to the halfway point when we're doing calculations in a projectile. The time to get to that halfway point here is equal to the time it takes to go from that halfway point to the ground. At this very top point, we know that that vertical velocity is 0. That final vertical velocity at the halfway point. That's crucial. So that VF equals 0 at the halfway point. VI, vertically, we know is 22.9. We know gravity, or the acceleration, negative 9.8. Okay? And that's all we know. Horizontally, all we know is the velocity, 19.3. So based on these vertical values, we can solve for the vertical distance using VIT. Oops, we don't have the time. We can't use that one. I'm sorry. We can use VF squared equals VI squared plus 2AD and solve for that vertical distance, the maximum height it achieves. Make sure you just use the vertical velocities. We can solve for the amount of time it's in the air. VF equals VI plus AT. Okay? If we solve for that time here, that tells us the time to get to that halfway point, just up to there. If we double that, that gives us the whole time back to the ground. So let's just say we solve for this t and it comes out to be, I don't know, 1.5 seconds. So the time that we would use vertically would be 1.5 seconds. Our time horizontally, if we want to know the horizontal distance or the range, we have to double that because it takes twice as long to get all the way back down and go through the entire thing. So that would be 3 seconds. All right. If you have any other questions about projectiles, we'll leave it at that for the basics right now. Just remember, once an object has left whatever made it become a projectile, the only force acting on it is gravity, the only acceleration is gravity, and it's all in the downward direction. Okay? Sometimes that's one of the basic questions that they ask, is the direction for acceleration, the direction for the forces on a projectile.